Okay, so let's get trucking since we need to make up for lost time. Sorry I didn't get the video up. I did record a video, but there was problems with Firebase when I was recording it. But I promise I've made a whole bunch of progress on the code that I'm going to go through, so we'll be able to streamline it, and I've added stuff to the presentation. But let's start off. If you remember from last class, we were working on our custom array adapter, right? And I've gone ahead and I've streamlined that. I remember before we were pasting some stuff in, and I was taking stuff out and things like that. I finished that, so let's just go through it cleanly now so you see it, because it's actually not that bad. Where it maybe seemed kind of intimidating when we were taking a bunch of crap out of it. So first of all, I just want to review this guy here for our custom list view. So remember when we first looked at list views, we just had that generic row where we had to put that text view in there and had to format the text view that special way instead of using our constraint layout and things like that just to make it work initially. Because the default, a list view shows whatever is in the associated adapter that we've connected to that list view, okay? And adapters work in terms of an array. So if we were to draw, a picture of that, just to give you a visual of how that actually works. Array of who what? I'm basically going to show you the picture here. Yeah, so we have this, we have our list view. So everybody's cool on what a list view is. Shows a list of things. Okay. Now, then we have a list of things that we want to show. And originally, this was just a list of strings. All right, and of course, that our list is in green, right? And our list view is in red. All right, so here's the issue. A list view is a collection of rows, right? And we built that little layout thing that is a row with a little text view in it, right? So we need to have something here in the middle that converts our list of strings, puts it into those individual rows, then delivers those rows to the list view. And that's our adapter. Okay? So here in the middle, we have something called an array adapter. All right, and of course that's in yellow. All right, so an array adapter requires three things to work. It requires the context, which for us, that's always the activity in which this is taking place. That has more to do with just how Android is architected. Whenever a layout shows up on the screen, it has to know which container it belongs to. So that's where that context comes in. So don't put too much weight on context at this point. Just kind of know that as far as our world is concerned, the context will always be a pointer to the activity where this guy's going to show up. So it's 99% of the time going to be this. In fact, for us, it's 100% of the time right now. Okay? So context is one of those words that seems kind of vague and maybe is a little intimidating when you have to use it. For us, it's just what room is this going to show up in? And leave it at that. So it takes a context. It takes a layout. We'll call it a layout row. And then it takes a collection of things. In our case, our initial case, that's going to be a collection of strings. All right, those are the three things that an array adapter needs in order to do its job. Now, I have the collection of things right here. It's going to be an array of strings. So this is one of the things we'll pass in here. Now, all of this is going to live inside of some activity. So that's the activity we'll pass in for the context. Then we created our XML layout with just the text view in it. That's the third thing. Make sense? So this array adapter, this guy's in charge of kind of making the sandwich. Say, give me the list of stuff, give me the layout for the row, give me the activity where I'm building this, and I'll smush them together and then deliver that information to the list view. So the list view can show that stuff on the screen. All right, make sense? That's the role of the array adapter, to adapt this array to work with this list view. And adapters actually go farther than that. They're not just for list views, they can be used for other things. But in our world right now, it's just list views.
Is it only a single array adapter per list view?
Correct. Yep. So basically, the answer is still yes, but inheritance could play a role there if you have dissimilar rows. Let's pretend like that's not a thing yet. But it's still just one. It just might be one that happens to be the same thing as something else, which is the same thing as something else through inheritance. But keep it simple for right now. So in our simple case for list views, I had an array of strings. I had a generic default array adapter. I didn't have to do anything special because the default array adapter knows how to show strings. All right, that guy, it actually knows how to show a couple of other types as well, but let's pretend like it's just strings. All right, so I didn't have to make a custom version of that because I'm saying, look, I have some strings. I want those strings to show up in a scrollable list thing over here. Make it happen. All right, so my default was I had a list of strings. Then I had my default array adapter of strings. I passed it my array of strings. I passed it my layout that just had the text view in it. And then I passed it this for the context. And then I let this list view know that his array adapter is this dude. And then it just worked, right? A couple lines of code, no big deal. All right, so now we're going to call this guy our simple list view. Okay, now I'm going to go ahead and copy this, and we're going to call this guy a custom list view. And really, actually, maybe the better use of this is instead of simple list view, we might say a simple array adapter. We can say they both kind of mean the same thing in terms of what we're ultimately producing, but in this case, we're using the default array adapter. In our custom case, we have to build our own specialized array adapter. Okay? Now, so let's say I have a list of, in my example here, patient records. All right, so that's what I actually have a list of. Instead of strings, I have patient records. And if you remember the previous assignment, we kind of had to keep track of two arrays inside of core. We had the actual array of objects, and then we had an array of string representations for those objects so that our list view can show those, right? So we basically just did the toString for every single one of them to make it look pretty, because that's all our array adapter knew how to work with is strings. Okay? But now we're saying, you know what? Why should I have to work extra hard and have some sort of weird string representation of my object when I can write my own custom array adapter here and give it a list of, in this case, patient records, and then have it be able to adapt that list or that collection for this list view? So what are the two things that change in this particular case? Well, chances are this layout row is more complex, right? We're not just showing a single text view. Maybe we have some vertical linear layouts, some horizontal linear layouts. Maybe we have 4 or 5 text views. Maybe we have an image view, all sorts of stuff. If you think about, apps that you might download and you scroll through, a cheesy one might just have a list of strings, but usually if you're looking through like movie times or something, you're going to have the big image of the movie. They're more complex than just a string. All right, so for us, we might decide, that makes some sense. Let's be able to make our own custom rows. Well, as this custom row, this layout row that we build becomes more complex, that is, it's not just a text view for holding one string. Now we have it custom designed to hold, the name of a patient, the age of a patient, 3 or 4 other things, whatever it is, maybe their picture, all sorts of stuff. More than just the string, okay? More than just a single text view. It actually then becomes easier for us because we don't have to go ghetto style with the layout. We don't have to take the constraint layout in and then put the perfect text view version in just to make it work. we could actually just build a normal layout like we're used to building for our normal interfaces. You can have vertical linear layouts and horizontal linear layouts because we're not reliant on the default array adapter to connect the dots for us. We're going to write our own array adapter. So we're going to call this guy a custom array adapter. I'm going to show you an example of that here in a second. So I'm just giving you the high level picture of what we're doing here. And there is one function in here that we have to override. All right, and if we go and look at the code here, this one function is this guy right here called getView. So I'm going to go ahead and put that in our slide here. And so for a custom, we must override the getView function. Purpose of getView is to return the view with all of the attributes of in this case, a patient record. Set to the right widgets within our custom layout. All right, so the default get view goes and grabs a single text view and sets that string to that text view set text. That's what the default one does. We want to do something more complex, so we're going to have our own version of an array adapter. We will override the get view that comes with that, the one that just hooks up a string to a text view. And we're going to say, okay, I'm going to teach this, my version of getView is going to show me how do I connect the various attributes from a patient record to the various widgets that I put inside of my custom layout that I built for my row. That make sense? That's the role of that guy. Because that's something that a default array adapter wouldn't have known how to do, because we invented patient records and we invented the row. So the array adapter that was created, years ago, wouldn't have known what we were going to do last week. Make sense? All right. So we have a pretty good picture of what we have to accomplish here for a custom array adapter. So if we look at the code here, our custom array adapter here, I named patient record array adapter. You could have named it whatever you wanted, but this guy is an array adapter for patient records. Kind of made sense to name it patient record array adapter. And notice that it extends array adapter. So he is a plain Jane array adapter, just like any other array adapters. That's what list views require array adapters. If we go back here to main, when we hook this guy up, we are setting that list views adapter equal to that array adapter. So one way or another, we have to tell, and this isn't new code. When we did this just for strings, we would have had to tell our list view the default array adapter we were connecting up to it. So that holds true with our picture here. Here's our default one. This list view requires one of these to adapt our collection of things. Make sense? So even in our custom version, our list view requires some kind of array adapter, in our case, a more powerful array adapter, let's say, to adapt our list of things that maybe is not just a list of strings, it's a list of more complex things. All right. So going back to this guy, so here's my patient record array adapter. Now notice the very first thing I do here inside of the constructor for patient record array adapter. So what does this guy do? He takes in a context, which is the exact same thing a generic array adapter took in. He takes in the layout that we created, so r.layout.my special row, whatever. This is the exact same thing that a generic array adapter would have taken in. And then lastly, it takes in an array. A generic array adapter would have taken in an array of strings. It actually used something called generics, but for right now, let me say array of strings. Okay, now so that's where I'm deviating here. I'm saying, okay, this guy's no longer an array of strings. Now he's an array of the thing that I want to show my collection of. Continuing preposition, deal with it. All right, make sense? Normal array adapters, I think I still have the code here. Well, here, I'm going to show it to you in the picture. Normal array adapters take a list of strings when I build the array adapter. Custom array adapters take a list of some kind of specialized object when I build it. Because this guy's job is to adapt this collection for this list view. That's his job. So if I have a default array adapter, let me see if I maybe just still have it commented out. If not, I'll just rewrite it real quick. All right, so if I do something like, I think I still have the patient strings up there. So if I do something like array adapter, let's call that AA2 is equal to a new array adapter, and I'm going to pass this guy the context. I'm going to pass this guy the r.layout. And my original list view row was just called list view row. That was the one that just had the text view in it. And then the last thing I passed it was core.the patient strings, a collection of strings. So this guy is taking a collection of strings as a parameter. This guy is taking an actual collection of patient records. This is the default array adapter that I didn't have to rewrite myself. This is the one that's built into Java or built into Android. This is the one, patient record array adapter, that I wrote in terms of the generic one. But this guy takes in the exact same context, the exact same type of thing for a row, although we presume it's probably going to be a customized row, right? Doesn't have to be. It could still be a row with just a text view in it if we just happen to want to pass in a single string or something. But instead of us having to create two separate collections, before we had a collection of patient records and then we had a collection of patient record strings, and we kind of had to maintain that patient record string thing, so we had something we can throw into our list view. We can say, look, here's my generic list view row, and then I'll go ahead and just give you real patient records, and then we'll overwrite that function to just squeeze out, maybe it's just the patient name or something like that from it. But in this case, we're doing something more complex, but the pattern is identical. So generic array adapters require you to give it an array of strings. Our custom array adapter we're building here, it could take anything we want here. We just happen to say, look, instead of an array of strings, we wanted to take in an array of patient records. All right? That was our prerogative because we are writing this guy. Make sense? Okay. So if I go into the code here, here's my constructor for patient record array adapter. This is the guy I wrote. He's going to take in a context just like a normal array adapter does. He's going to take in the ID of our layout row, just like a normal array adapter did. You go back here, look at the value we're passing in here. This is r.layout.listViewRow, which is just going to be like an integer, unique phone number, unique social security number for that layout. Similarly, we passed our advanced row here, but it's still going to be just an int. So these first two parameters are absolutely identical to what gets passed into our normal array adapter. This third one is a patient record list, which is, well, patient record array. We're going to be upgrading it to linked lists here soon. That is where we've deviated from typical array adapters. Now, actually, a typical array adapter would allow you to pass in an array of patient records. What it wouldn't know how to do is it wouldn't know how to build a view from those guys. So the fact that we rewrote this constructor wasn't all that important. It was, we did have to do it, and I'll show you why here in a second, but the real magic of the custom array adapter is the get view. All right, so what we did here is we went ahead, since a patient record array adapter is a array adapter. This is inheritance, right? So if we were to draw a picture of that guy, we have our plain Jane array adapter that's built into Android. All right, we can't modify that dude. But then we said, you know what? We're going to make a patient record array adapter. Now, this is the dude that we made, and we built him in terms of the default array adapter. So he started off as a normal plain Jane array adapter. And then we wrote some code in here that differentiated him from that a little bit. That makes sense? That's how inheritance works in any object-oriented language. All right, and if you remember, we actually have another level here that we don't even really see, where an array adapter at some level above here, there's probably several levels actually, the very top, it's going to be an object. So an array adapter is an object, which is a patient record array adapter. If you want to see the full dealio there. Somebody scream at me before you let me click on this thing right here.
Wait, why?
I was putting quizzes in this morning, so you might see student grades. It might have timed out by now, but better safe than sorry. What was I doing? Oh, yeah. I'm just going to search for Android array adapter, and this should bring up the array adapter class for me here. Yeah. So an array adapter, and this was that generics thing I mentioned. It could take in any type. It doesn't have to be a string, but you'll still have to rewrite the get view in order for it to do it correctly. But an array adapter is actually a base adapter, which is actually an object. So if we were going to correctly draw our picture here, there's actually one more level in here that we had nothing to do with. A base adapter. So the hierarchy we have right now is everything in blue Android people wrote. All right, we had nothing to do with it. Okay, we want to make something that's kind of a specialized version of an array adapter. It just so happens that an array adapter was built in terms of a base adapter, which I'm not sure what that guy does. We can go and explore it, but let's not use the time. Which was built in terms of a generic object. That make sense? Now, the idea is that if I click on base adapter in there, it'll show me other guys that also use base adapter as their thing. So if I click on base adapter here, it'll probably show me known direct subclasses. So array adapter, cursor adapter, simple adapter. So those are 3 different objects that were all built in terms of base adapters. Make sense? So this is how object-oriented programming works. That one of the goals is we don't want to rewrite too much code. So they decided, you know what, we have 3 different classes that all have a commonality that is the stuff inside of base adapter. So we'll write that single commonality, then we'll write those, in this case I'm just showing you one, but those 3 other classes, pulling in those common aspects and then differentiating themselves internally. So this is what was provided to us. We don't have to worry about base adapter or object in here, other than the fact that an array adapter gets all the stuff from base adapter. And a base adapter gets all the stuff from object. All right, so an array adapter is an object, which is also a base adapter, which is also its own specialized thing called an array adapter. What we've decided to do is we need even more. We need an even more specialized version of array adapter, so we're going to write our own here. Okay, make sense where we are in the world here? Okay. So the only thing we've coded is this piece here. We just happen to be building on top of a mountain that already existed. So in our custom array adapter here, which we've let Java know we intend to build on top of the array adapter mountain, we're building on top of that class, we're going to take in the exact same stuff that an array adapter took in. All right. So we went ahead and we took in the context, the layout, and then our list of stuff, our array of stuff. We went ahead and just in case there was something special that an array adapter did, hooking up some wires that we don't really know what's going on here because since we didn't write this guy, we don't know what kind of magic happens inside of there that was required to make this guy work. And we don't necessarily know what kind of magic happened in here to make this guy work. So the very first thing we're going to do in our constructor for patient record array adapter is we're going to go ahead and call upon the normal array adapter constructor so it can do any specialized magic that might have to get done. Okay? And this isn't an array adapter lesson. This is a whenever you inherit from an object lesson. Unless you directly control the object above you, it would be good programming practice to always call the parent's constructor in case it does something that you're not aware of that is integral to it functioning. Okay? And that's what I'm doing right here. And it has to be the very first line. So we'll add that to our notes here real quick. So when I say super, I'm saying I'm talking about my parent. And when I use super like this, where I just say super and then parentheses after it, I'm specifically saying call my parent's constructor. And this guy's parent is array adapter. Make sense? So I'm saying I'm going to go ahead and call the array adapter constructor. I'll go ahead and pass it the context. I'll pass it the row thing. I'll pass it the list that I have. Now, I don't necessarily know what it's doing with all those things. But presuming there's some sort of magic that's occurring in there, there might not be. This might be a complete waste of time, potentially. But safe thing is, if I'm going to build myself in terms of something above me, let's go ahead and let that guy do his initial foundation. And then I'll differentiate myself here. So I actually kept track of the context myself. I kept track of my patient record list myself. And I actually kept track of my text view resource ID myself. I could have gone and done some research and looked into what were those variables called in here, and were they private or were they protected? If they were protected, then I would have had access to them in children of array adapter. But instead, I said, look, do your magical setup. I'm just going to locally handle these other three things and not worry about what happened to them above. Go ahead. I don't believe it is. You could probably get quite a bit of information about it, but the actual implementation, I believe Java is not open source. So let's say no. It's possible they may open source like older versions of Java because they're on like Java 9 right now. So it's possible you might be able to kind of take a peek in. Although, hold on, this guy, Array Adapter is not Java. Array Adapter, it's a Java class, but it's written for Android. And Android is open source, the operating system. I don't know if the Android SDK is open source. The answer to that might be maybe. So you might be able to see it. Okay, so punchline is if you really cared about these 3 lines of code here and you really wanted to just perfectly integrate with the guy above you, you probably can look into it and maybe avoid keeping track of a couple of these things yourself. But all I'm saying is, Array Adapter, do any sort of special magic you do, and then I'll just keep track of the 3 things myself anyways. All right, so that's what I'm doing here. I'm taking these 3 things. I'm going to go ahead and let Array Adapter do his baseline build. Then I'll just remember those 3 things that I passed in, just in case. I'm remembering them locally here. It's just private fields. All right, and then the most important thing for making your own default array adapter is this get view. We have to write our own version of that because the default one just sets a text view equal to a string. Okay, so the thing I'm going to add to the notes here real quick is this super thing. Super is how an object refers to its parent for within itself. Okay, so super is similar to the this keyword. This is how an object refers to itself from within itself. Super is how an object refers to its parent from within itself. That is the dude he inherits from. Okay? So if we intend to use our parent's constructor, it must be the very first line in our constructor so that all of the initial setup happens, and then we can further differentiate ourselves from that object. And the format for that is super, open parenthesis, then whatever parameters the constructor of the parent takes. Make sense? Otherwise, if you want to call functions and things like that from your parent's class later on, you can say like super.toString. All right, and if you're a normal plain Jane class and you're overwriting toString, your toString will be the most local one, but if you want to also utilize the one that came from object that gives you the crazy memory address, you can say super.toString, and that'll get you the crazy memory address, which you can then incorporate into yours if you want, that kind of stuff. All right, but for us right now, this is the important thing. If we are going to use our parent's constructor, which we should always use the parent constructor when we did not build the parent ourselves. If we didn't play a role in building that parent, like we didn't build array adapter, we don't necessarily know what kind of voodoo is happening inside of that constructor. So we're going to go ahead and just say, look, do your build however you do your build in case something weird happens. Then I'll differentiate myself. So it's kind of a black box from that perspective. Make sense? The Android people built it reasonably, and we'll just go with that. And this is an object-oriented programming lesson, not an array adapter lesson. We just happen to be looking at it through array adapters. So this stuff here, well, all that stuff, all of this stuff is actually language agnostic. Doesn't matter whether we're dealing with Java, C#, C++, all the same. Super is the keyword, and all these rules apply. Okay? So now, so we're good on this constructor thing here? Nothing super special in there, just I need a constructor for my class because I need to take in those three things. I'll pass the buck to my parent with those three things, let him do his magic. Then because I'm not necessarily sure what my parent was doing or because I'm lazy, I'll just go ahead and keep track of those three things myself just in case. Okay, and usually my style is I would say this dot before all these. So just to be specific, I would also typically name these the same as I named them up here, but I didn't here, so just roll with it. All right, so I'm keeping track of these three things here just because, look, if I need them in a few minutes, I don't want to have to go and figure out how to get them from my parent. I'll just use them locally. Okay? But this is the magic. So this override thing here actually is not required. When you go to start typing in GetView, it'll put it in there for you. So it actually is a convenience inside of Android Studio as well as Eclipse will do this. It's not required, but it does help with performance. All right, so any of these little things you see in Java that have a little @ symbol, these are performance benefits and are almost always not required. I'm going to show you pretty quickly here where it is required when we start talking about Firebase. But I'll explain why it's required in that case. It's Firebase that requires it, not Android. Okay, but don't worry about Firebase right now. That's another thing. Not a hard thing, just another thing. It is a hard thing though when Firebase is down when you're trying to make a video about it. I was sitting there for like 45 minutes talking to myself, like, okay, let's try this, let's try this, let's try this. And finally I finally decided to look, like, oh, was Firebase even up? Because everything was failing. Firebase is like super easy to set up. And finally I went to like, is it down? Yeah, Firebase was down. So I'm sitting there for 45 minutes making a video where while I had students outside shoveling my driveway. And yeah, it was just a waste of time. But
How many people actually showed up for that?
huh?
How many people showed up to like shovel you out of the driveway?
I had 3 students. They were like all roommates.
Oh, nice.
So they made $150.
Not bad.
Yeah, and then one of them came back out yesterday to finish digging out my mailbox, which got reburied. Yeah, so that snow cost me like $200, plus another $40 in sand. So $240 for that snow. And now it's 40 degrees today, so it's all gonna melt. What do you do? It's one of the joys of Wisconsin, right? Okay, so this override thing, not required, but if you, if I were to start typing in, here, I'll fake one of these. Like I'm going to override this guy right here, the get text view resource ID, which actually is the, I could actually cheat here. That is a getter for text ID. So that tells me right now I actually didn't even need to store this guy here. I could have just asked my parent for it. But whatever. Let's say I was going to override that guy. I just started typing it. If I press enter, oh, I expected to put override. Oh, it's public. Let's see if I can give you a different one. Yeah. So I chose get item and notice that it went ahead and put override above it for me. It also filled in all the stuff here. So you don't have to worry about going and copying and pasting it from some website or something like that to make sure you have the right parameters. So this guy has 2 things: that it's not nullable, so it always has to return something, and we're overriding something else. These guys are not required. It will still run without those, but it'll potentially run slower. Okay. But at the end of the day, the object-oriented lesson here is the default array adapter has this method called getView. Okay, and the default one, it takes a position, all this stuff. This line right here is identical to the parent one. The only thing we would be allowed to change is the variable names, because Java doesn't care what you name the variables. It only cares about the type. So we would have to write a public view getView that takes an int, a view, and a view group. Those are the 3 things that we would need to take in as parameters. Okay, so I went ahead and let Android Studio fill it in for me. So I have that dude there, and then I'm going to write my own version of getView, because the one that's built into array adapters only works for single strings. Make sense? All right, so now there is an efficiency thing built into list views, as well as this is the same thing is true for iOS programming. You know, so when you have something that has 1,000 rows in it or something like that, instead of building 1,000 actual rows, let's say that maybe 15 of them fit on the screen at once. It might build 20 of them, so that you have the couple before and a couple after, and then it reuses those as you're scrolling to be more memory efficient. So rather than having 1,000 rows stored in memory, it'll just have 15 of them. And then whatever is visible, it'll make sure it slides the special data into that particular row before it shows up on the screen. All right, so basically as you're scrolling, and sometimes on an older version of Android or something, you might be able to fake it, where you can scroll really, really, really fast, and you'll see the data in the row changing as it's scrolling up, okay? Because what it does is it reuses those rows. So it doesn't have to, because we only care about what we see on the screen, right? If there's a row that's off the screen, doesn't matter what data is in it. When it scrolls back on, we just want it to be the correct data. So before it gets onto the screen, we'll change that data out that's on there, because we'll reuse the existing one. And that's what's happening right here at the beginning. All right. So when we're getting the view, this is effectively an array adapter saying, I need to get the view that's associated with position, whatever, position inside of my patient record list. So I want the view associated with maybe patient number 7, or I want the view associated with patient 13, so on and so forth. Okay? So this is telling me what row am I getting? Okay? Then it's going to try to give me a view. Notice this guy is nullable. So this dude might be null. So it's going to give me an old row if there happens to be one available. So I can just rewrite it. Otherwise, I'll have to build a new row. So the first time through, we're building rows. But as we're scrolling and things like that, chances are we're going to be reusing already built rows. All right? And the last thing is who's my parent view group that I'm building this in? So this very first piece here, and I put a comment above here, this guy says, I'm going to go ahead and get my, this is my row. So I called it list item. So I'm going to have a view list item is going to be equal to convert view. I didn't have to do that. I just threw it into a local variable. All right. Then I'm going to ask a question about that. I'm going to say, if it's currently null, that means it isn't a row. It needs to be a row, but it currently isn't one. All right. So I need to build it at least the first time. That's where I come in here. I say list item is equal to, and I use this thing called a layout inflator. I think I mentioned this last class. This is kind of like bringing a clown in to blow up a balloon. Okay, so we pull the balloon out of the bag. That is our r.layout.row item, whatever we call the thing. Okay, that's the balloon here. And I blow it up. So I inflate that guy from within our current activity, the current context. So I'm going to say I'm going to inflate from the current context the resource ID that I passed in. I'm going to put it within the parent view group that was given to me right here. And it's asking me if I want to attach it to the root. I'm saying no. 99% of the time you'll say no. Just don't worry about that for right now. That has to do with how screens are laid out and things like that. It's not important. Just put false there. Okay? So if I don't actually have a row yet, go ahead and blow it up. Now I have a row. So after I get past this if statement here, whether I got in the if statement or not, I know that list item has a row that I can now fill stuff in. So what am I going to do? I'm going to go ahead and grab my patient record from bucket position. All right, there's nothing new there. I'm just getting my patient record list is a collection of patient records. I'm saying get me the patient record that lives at bucket position. And I'm storing it in a local variable called PR. So I have a patient record there. Then I'm going to take the attributes of that patient record and I'm going to throw it into the places inside of my custom row. So for this, I'm grabbing a couple of text views. So I'm going to have a text view for the name. I'm going to have a text view for the age. So this is, instead of saying this dot find row by ID or find view by ID, I'm saying list item, which is my row. So I have this view here. So I have my inflated row. I'm saying I want to use my inflated row. I'm going to look in there, and I want to find the view that is the text view for my name. Similarly, I'm going to find the view from this guy that is the text view for my age. This is no different than we've been doing inside of our activities all along. If you look back at like main activity, right here, I'm setting my list view equal to the list view version of this dot find view by ID r.id.list view. I just happen to be looking inside of a view that was given to me rather than the view associated with this activity, which is the content view of this activity. This guy right here. All right, so nothing new here. I just happen to be searching inside of a different guy. All right, so I get my row. That's a view. Then I'm going to say, go ahead and grab my couple of text views from that view. And then I'm going to set the text in those text views equal to whatever I decide are the appropriate functions from my patient record. So this is where I'm differentiating myself. I'm saying, what does it mean for a patient record to be loaded into this row? It means grab my 2 text views from my row, just because I happen to know I built my thing with 2 simple text views. I could have put 50 text views in there and images and crap like that, but I don't have all the data for that. So I just happen to know that this layout has these 2 things in it. So I'll grab those 2 things. I'll set them to the appropriate pieces of information from my patient records. And then ultimately I'll return that row, because I'm returning a view here. So as we are scrolling through, well, as it's being initially built, and as we're scrolling through, the list view will tell its adapter, I need the next row. The array adapter will go and return row position as the list view asks for it. Okay? And it's only going to do this for the ones that are currently showing on the screen. So if you happen to have 1,000 rows, it's not going to make 1,000 rows. It's going to show the 12 rows that are on the screen, and then probably fill in the next 3 or 4 on either side, just so you can keep up when you start scrolling. But then it's going to, as this guy scrolls off, he's going to reuse him as he's scrolling onto the bottom. He's just going to drag it down here, fill it in with new data, and reuse it. All right, so we're only calling this for the stuff we see plus a little bit more, not for all 1,000. Because there's a decent chance you'll never scroll. Mm-hmm. Right? So why use that time or memory? Go ahead.
Is that like one box off the screen? Or is it like 2, 3?
I don't know what the exact number is, but it's probably 2 or 3. Yeah. It's whatever they've deemed is enough so that when somebody starts scrolling aggressively, the processing power is enough to keep up. Okay. It might even be adjustable based on the speed of your phone. Android might look into it and say, if you have a latest generation phone, we'll just do 1 or 2. If you have a elderly phone, maybe we'll do 8. Something like that, just to give yourself a little bit more time before the next thing scrolls onto the screen. So that in that case, you're trading off a little bit more memory usage. You're bringing more rows into existence to make up for maybe the lack of speed you might have. Okay, but that's not on us. Behind the scenes, magically, it's doing that. In fact, we actually see it at a more efficient level now, because actually, if you notice when we were doing list views, it's underneath like antiquated legacy stuff for the views, because the new way of doing these is something called a recycler view instead of a list view. It's okay, but it effectively is an optimized version of what I'm talking about, where we're recycling rows that aren't on the screen that previously were on the screen to fill them in with new data. It's just a new approach to doing that. So they've built kind of a new architecture around it, but we're not building, crazy interfaces, and list views are pretty easy to work with. All right, go ahead.
So like the list view in Android, they have the automatically like the scroll thing already?
Yeah, but we don't have to worry about it. That's all done for us. There's nothing special we're doing. It's just a list view scrolls. That's just part of its nature. Yeah, so it won't scroll if you have a big list view like that, but you only have 3 rows in it. Then there's nothing to scroll. But if you have 1,000 rows in there, it'll scroll. You don't have to do anything special. It just works. Okay, so if I go ahead and run this, let me comment out a few things here. Here's me filling up my patient records.
Can you show what you have in your screen so far?
Which one?
The activity main and the
Yeah.
like not the code but like the actual interface.
Yeah. Give me a second. Yeah, so my activity main looks like that. So just a button and a list view. And then I have here's my advanced list row. This is the one we're actually using. So notice it has two different text views.
Okay.
One's called name TV, one's called age TV, and you see us using those right here. Name TV and age TV. That's like the magic sauce here. Okay, we designed our special super complex row that only has two text views in it instead of one. We named them, and then inside of our get view, we tell our custom array adapter how to deal with that special super complex row. Make sense? That's why we have to write our own version of get view, because it's not going to be able to guess at what we called our text views or if we have images or any of that stuff. And it's also not going to be able to guess what am I going to put inside of name TV. You know, it doesn't know that I happen to build a function inside of patient record called get name string. It also doesn't know that I have a get age string. So I just wrote two functions in there. So if you look at patient record here, don't worry about a lot of the stuff that these are public and stuff. That's a Firebase thing. But here's my get name string and get age string. So get name string just returns their name. Get age string just returns their age in like a string formatted way with like the word age with parentheses around it, stuff like that. Good.
Are we going to use the exclude also for Firebase?
That's a Firebase thing, yeah.
Okay.
Yeah, anything that looks new to you in here is Firebase.
Okay.
So, yeah, but we get this, right? Plain Jane, this is just a function that returns a string. Happens to be called get age string, and what am I doing with it? I'm just building a little formatted string that says age with parentheses and then puts the number in there. Okay? Nothing special. I just happen to be using that inside of my custom array adapter here where I say I want this particular instance of patient record to give me his age string. And I'm going to load that age string into my age text view. Make sense? All right. So just want to make sure I have the Firebase stuff disconnected here. That's good. Yep, I think I'm good. All right, so I'm going to go ahead and hit play here. All right, we see all of our rows. I don't know if there's a way for me to zoom here, but just trust me. So we have first name, 73, last name. Oh, don't worry about the 73 thing. That's a Firebase thing. I have to store middle initials as ints. Just pretend like their middle initial is 73. That's the Unicode character for it. All right, so just a really weird way of storing their middle initial. It's like an alien world, and middle initials are actually numbers. Okay, and then age 0, age 1, age 2. So actually all their ages are 0 right now because I must always be putting a 0 in there inside of my default constructor for patient record. Yeah, I'm always putting a 0 in there. That was just my way of building a whole bunch of patient records really quickly. So I could make that a random number, but it doesn't matter. All right, but punchline here is we have a whole bunch of rows, and each of these rows has two text views in it instead of one. Super awesome custom array adapter. Make sense? Now, just to show you the change there, if I go into my array adapter here, and instead of putting my age string inside of the age thing here, I can, put like hello world, stuff like that. So this is my own. I could fill up this thing with whatever I want, because every single row is going to call the getView function here inside of my custom array adapter. So right here, I'm saying I'm not even going to use my patient record to get his age stuff. Instead, whenever I'm putting something for the age, I'm just going to say hello world with some extra squigglies and stuff like that, just stuff. So now when I run it, you'll see that every single patient record has that hello world, blah, blah. And there it is. Hello world, blah, blah. If I happen to want to see what row that is for, I can concatenate on position. So that's what gets passed into get view. So it'll show me this is the row for bucket for position 0, position 1, position 2, position 3. So that guy will change. I'll run that again. All right, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 13. If I scroll a little bit more, now it says 14, 15, 16, 17, 18. All right, so I scrolled a whole bunch. Now we're at 224. When I scroll back now, it's reusing rows.
But I see like the scrolling making it, like longer. Like the less list you have, the bigger the scroll.
Yeah.
Does that affect anything, or is it just a user interface?
Well, I mean, it's because the numbers go from 2 digits to 3 digits.
No, I mean the little scroll on the side.
This guy here?
Yeah,
Well, it's because I have 1,000 things in there.
because you said reuse, so.
Well, yeah. I mean, it's still showing you like how many there are in there. It just happens to be the way it's showing. When I scroll down here, it's going to show me some rows up here, but it's not creating brand new rows. It's using rows that previously existed. In fact, it's probably taking a couple of these rows here that I'm not seeing now, moving them up here, and that becomes the next thing that shows up onto the screen up here. Yeah, so it has nothing to do with how many elements we have. It just has to do with the mechanism it's using to display those elements on the screen. Okay, so that makes sense for our custom array adapter. So not that big of a deal. It's a normal array adapter, and then we just rewrite get view to adapt to what our specialized rows look like.
I just have like a general question. For my code, why would the list item be underlined? What would that mean?
Which list item? This guy here?
Yeah.
Well, my guess is it underlined like in orange or yellow?
Just black.
Just black? I don't know.
Okay.
I mean, if you highlight over it, it should tell you what it maybe
I
is.
think it doesn't come up with an error. It just says it's just underlined.
Yeah. But I mean, if you highlight over the word,
Oh.
highlight under the underline, it might tell you what it's confused about. Okay, so that's array adapters. Now, let me show you Firebase. Drew a little picture here. Where did I put my picture? Oh, I didn't draw that picture yet. That's fine. So right now, when our app is running, we are storing stuff inside of core in our app, right? All right, so this is from our previous assignment. All right, but now what we can do, because now we have a custom array adapter, is I can choose not to store a collection of strings. Because now my array adapter knows how to display information about patient records. Right? So I don't need to have that extra collection of strings there. Make sense? That's what we just gave ourselves, is the ability to adapt patient records for a list view rather than using a generic array adapter to just show strings. Okay? But the way we've done things up to this point is when I'm on, so here's my main activity, when I'm on my second screen for adding a new patient record, for you guys, your second screen was for adding a basketball player, right? When I'm on my second screen for adding a patient record, after I create it, when I hit submit, it creates that new patient record and it stores it up here in core, which is our singleton. That allows that information to be shared between these two screens, right? Okay, and then when I come back here to my main activity, it's my list view gets updated because array adapters automatically update. You could also force them to update if you don't want there to be a little delay, but whatever. They will automatically update eventually. They have like They notice when changes have occurred. All right, so we're using core locally here for doing that. Now let's say that we've taken the time to go ahead and put in 50 patient records, which would be pretty tedious when you're testing your assignment, right? What happens when you stop your program and relaunch it? All of it's gone, right? Because we haven't stored it anywhere. So all this stuff, even though we were putting it in core as we went along, this is all local relative to a single run of the application. We haven't stored our stuff anywhere. Now, one thing we can do, just going to shove Firebase out of the way here for a second, is we can create a local database. Now, the local database that is built into Android, and I'll actually show this to you. Well, actually, I don't want to show it to you because we'll almost always be using something. But this guy is usually something called Sql Lite. All right. So if we think about databases here for a second, what is a database? A database is a place that stores data, let's just say long term, not for a particular run of our application. Now, you can just have a database that's not related to an application. It's just a place that you're going to want to have, maybe, for instance, here at Concordia, as a student, you have phone numbers and all this stuff. You are stored in a database somewhere that then our database administrator can run reports off of and get your grade reports. And when you go into Banner and it's, it shows you your current transcript and that stuff, it's pulling from all that stuff we're storing in a database. Okay? So a database in and of itself is a place that stores data long term. And then we could probably say it is usually searchable / queryable. I'm assuming that's a word, but we can, and usually when we query this, we're using a language called SQL, structured query language. All right, so this allows us to, once you know SQL, you can use most modern databases because they all are SQL compatible. So I'm saying I might go and talk to any sort of SQL compatible database, and I'm saying, give me all students. I would say select maybe I want phone numbers. Select phone number from students where class or registered class is equal to CSC300. Something like that. And now we get a list of all your phone numbers. That kind of thing. Okay? So that's what a database is in general. Now, these SQL-based ones, these are actually called relational databases, and I'm not going to test you over this. This is something that you'll learn in Dr. Wall's database class, 430. But let's say that that a huge majority of our databases today are relational databases, but they're actually they're falling out of vogue. They're being replaced by what are called real-time databases, or what are called NoSQL databases. Relatively unimportant, but Firebase is one of those. All right, but relational databases almost always use SQL. And then I'm just going to say real-time database, also called NoSQL databases, almost always have an SQL-like query language, as well as programmatic ways to query the data. All right, so these real-time databases they kind of exist with this explicit purpose of supporting applications, websites, mobile apps, that kind of stuff. And with that in mind, they figure that the people that are going to be asking information of them are likely programmers who might be more comfortable with using objects to say, give me information that meets some criteria, rather than creating these crazy looking SQL queries that join 9 tables together with inner joins and outer joins and all sorts of crazy stuff. SQL is super, super powerful, but you have people whose entire job is to become masters of SQL. for generating reports and things like that. Where typically, if we're using a real-time database as part of an application, we're probably not spending a ridiculous amount of time designing a database that is perfectly optimized. Relational databases came out at a time where memory was expensive. So one of the goals of a relational database is to not duplicate data. Get things as separated as possible. Today, we have tons and tons and tons of memory, so actually when you use Firebase, by default, your data is probably repeated hundreds of times without you even doing it. Because Google is repeating it so that whenever somebody queries your Firebase real-time data store, it's going to go to whichever one of their servers is least busy right now to give you your data. So the problem is on the other side now. So now it's like, it's all about speed, not about footprint. Who cares if you duplicate your stuff? It's fine. Okay, so just the mentality has changed a little bit. But but I don't want you to think about it from the perspective of relational databases are dead and the new kid on the block is real-time databases. We're still talking about this from the perspective of use the right tool for the job. If you are a database administrator working at a place like Concordia or a big company or something like that, relational databases are probably still your way to go. If for no other reason, it's because that's your kung fu. Okay? You're awesome at SQL. So you might as well use, like, for instance, how many of you have heard of the company called Oracle? Do you know what Oracle makes? See, Oracle's always like a funny joke. It's like, we've all heard of Oracle. We always see their names as sponsors of different things. In fact, they have their own basketball, the Oracle Stadium, Oracle, arena is in Miami, right? Yeah, it's the Miami Heat. So, I mean, they have a basketball arena. What do they do? Okay, the guy who runs Oracle's in the top 5 richest people in the world. Larry Ellis. What do they make? Oracle makes, well, besides buying Sun Microsystems and now making Java, Oracle makes, let's call it arguably the fastest enterprise database management system called Oracle. So they make a database. They make a relational database. It's the database that Amazon, I think, is still using right now. They're moving off of it to their own cloud store stuff because now when these big companies start getting big, and bigger and bigger and bigger, they don't want to be reliant on other rich companies because another rich company just pull the plug on them. Like until, I think it's actually maybe still up there. Netflix uses Amazon services for their streaming because that's how, but now Netflix obviously has enough money where they can build their own server farm for streaming stuff, right? But Amazon, if you have an Amazon Prime membership, you have streaming service from Amazon, don't you? Do you think Amazon, it would be in Amazon's best interest to maybe make Netflix a little bit less reliable? To make more people subscribe to them? So they could just pull the plug? They probably wouldn't because that would be huge lawsuits and stuff like that. But punchline is they could. Okay, so Netflix, being a company that wants to make a lot of money, probably doesn't want to be really reliant on one of their competitors. That would be bad, right? But that's what Oracle does. Oracle makes a database management system, which is a relational database. And a lot of companies with a lot of money use Oracle because Oracle's really high performance. Other relational databases, so here we'll just throw a couple out there. So we have Oracle, we have SQL Server. One little warning I'll throw out here is don't confuse the 3 letters SQL with the name of a database. That is the query language that most of these databases are compatible with. So this guy is Microsoft SQL Server. That's their relational database product. And this is an enterprise one too. Microsoft SQL Server, you're going to have fanboys of Oracle versus Microsoft, and you'll probably have each one of them say the other one's better. I think it's fairly well accepted that Oracle is probably the fastest, but it's also really expensive. Microsoft SQL Server is probably good enough for 99% of enterprises. And if you're in a Microsoft shop where everything else you're doing is Microsoft, that's probably the guy you're using. Popular one that maybe a lot of you have heard of is MySQL. MySQL is a free relational database that, let's call it, pretty good performance for being free. I mean, if you really push it, it's probably not going to keep up with Microsoft SQL Server and Oracle, but it's free. So, yeah. So you have those three. And then the one I just pointed out here is called Sql Lite. And this is really a single user DB. So SQL Lite, that's why I mentioned like Android as well as, iOS wouldn't use SQL Lite anymore, although you probably still could because iOS has something called Core Data, which allows you to store stuff locally. So they've kind of replaced it. But punchline is that SQL Lite is not meant to be a database that has a whole bunch of individual people hitting it all at once. It's not meant to keep up with that. It's meant to give you a local storage place that's queryable with SQL. So it would make perfect sense for when you shut down your app, store all your crap locally, and then when you launch your app, grab all that stuff again, load it back into your Listview so you didn't lose the work from the previous time, right? But if your phone gets sawed in half, you've lost all the stuff. Well, unless it missed the memory chip. If your phone gets shredded. So you get it. Most of what we do today is we like to have cloud storage stuff, things off of the device. Make sense? When you have an app and you get a new phone, you want to be able to get to your new app or your new phone, log back into the app, and all your data is still there. Make sense? So we're not storing stuff locally on devices very often anymore. So this idea of using SQL Lite, while it might be kind of quick and dirty and serve a local purpose, more times than not doesn't really help us. Okay? I'll show you an example of it at some point. There's actually, Android has a abstraction that lives on top of SQL Lite where you can actually just add stuff to something almost like put extras on an intent, and it just lives on the device. It'll just make it happen. So it can do that type of stuff, but Firebase is cooler, and that's really the way that a lot of applications work today. And then real-time databases, these NoSQL ones. I'll just put Firebase in here, and then I'm also going to put MongoDB. There's some other ones, but the MongoDB is probably the most popular one. The problem with MongoDB is it's a free database, just like MySQL, but then you got to find a place to host it. So you could put MongoDB locally on your computer, and that's your server. So I'm storing it in the cloud. Okay, but if your code, your Android application lives on your computer, and you're always running it in the emulator, and your database also lives on your computer, and your computer gets shredded, you've lost everything. All right. So a weakness of MongoDB as well as MySQL is you need to find a place to host your database, store it somewhere. MySQL, most of your website hosting options like GoDaddy and stuff like that, they offer unlimited MySQL databases, so you can host it there. MongoDB is less popular for that now because it's really for programmers, not for people who are making websites using some of those like default web building tools. Firebase, this is my favorite one currently. Before this, I used one called Parse, but they got bought and then shut down because they were a competitor with somebody else. Firebase was its own product for a long time, but then Google bought them, and now Google's all in with Firebase. So Firebase is effectively Google's cloud platform, so I don't think they're going anywhere. In fact, Google does all of their push notifications for mobile applications through Firebase now. So I think this is pretty reliable. And it's free until you have so much data you're moving that it's not free. So for us in here, it's never going to cost a dime. You don't have to put a credit card in or anything like that. Okay, but these are kind of our two different worlds of databases here. And in our picture down here, if we have our local database like this, if our machine gets sawed in half or our phone gets sawed in half or whatever, it's gone. Firebase puts that up in the cloud. And we're going to say hosted by Google. So I'll put that guy in pink. Maybe we don't want to use that, but hosted by Google, this guy here, that's a good option. All right, Google, pretty good host, not going to lose their data. Firebase, real time, pretty fast. And I'm going to show you some cool things Firebase lets you do that Mongo does not let you do. But Firebase is what we're going to look at. Okay? Questions about all that stuff? I know I went pretty fast, so you might want to rewatch some of this video. For your homework for next class, we had the assignment that was due last Thursday that I gave you until Tuesday to turn in again because it was a little complicated. I went over it last Thursday. Mm-hmm. What we're going to do is we're going to update that one for your basketball players with a custom row. So custom array adapter, custom Listview row. Make sense? All right, so I'll push, actually my code from today is already pushed. I'll push it again because I put a couple comments in there or something, but I'll put that assignment up. So assignment for Tuesday has nothing to do with Firebase. I've just introduced Firebase. So the assignment for Tuesday is the custom array adapter assignment.
So
Make
basically
sense?
what we did today in class.
What we did today in class. Yeah, yeah, that I should, correct. What we did today in class that I went through. Yep.
Okay, question. Did you read at my essential or whatever?
Yeah, I did. I'm sorry, I didn't reply. It looks pretty good. I have a couple of notes. I'm going to reply before 1 p.m. today.
Okay, because I want to know what is your expectation and then like the
Sure.
you need to do the certain things.
Yeah. Actually, what are you doing today at 1 p.m.? Are you working or something, or are you free?
1 p.m. I have class with Dr. Long.
Okay, yeah. I'll reply at 1 p.m. to it because I have our meeting and then I'll reply back after that. I have my notes.
No,
I'm just 2 days behind on
I just
everything.
I just want to make sure that you have the thing.
I do.
Because I didn't start your project yet, so
Yeah, I get it. Yeah, so you're on my list, but I'll put you to the top. It's not your fault. It's the snow's fault.